Good morning to everybody. My name is Sergio Savaresi and I'm from Politecnico di Milano. And today I would like to make a presentation about the so-called robo-taxi mobility. Specifically, I would like to briefly show you some results of a research activity we have done recently at Politecnico di Milano. I take the opportunity to thank my colleague, Professor Silvia Strada, and the PhD student Davide Penati for their collaboration on this research activity. So first of all, let me start with a few words on, say, the classical megatrends. As we all know, the most important megatrend that is going to affect the future mobility is the problem of CO2 anthropogenic emissions. So in this slide, there is let's say a summary of what happened and what is going to happen. So in brief, starting from pre-industrial era, essentially, we have burned the fossil fuel and put in atmosphere about 2,000 gigatons of anthropogenic CO2. This created an increase of temperature of the planet of 1 degree. We all know that we have absolutely to limit the additional, so the total increase of temperature to 2 degrees. So hopefully 1.5, but more realistically 2 degrees. So it means that the human race has a so-called residual budget, which is no more than 1,500 gigatons of CO2. So that's the budget that human race has. And what is really interesting is that the equivalent amount of oil corresponding to the residual budget is just a tiny percentage of all the oil resources we have. And this is just oil, considered also coal, consider also natural gas. So it means that all in all, only a small fraction of fossil fuel resources can be burned. So we have to move as quickly as possible to a CO2-free, fossil fuel-free production of energy. And mobility has a big contribution in this CO2 production, so we have to change the model of mobility. So what is going to happen in the future, let's say 10, 20, 30 years, it will be a transition, indeed a revolution from our traditional mobility model that can be summarized with these 4 statements. So big cars, let's say powered with fossil fuel, personal ownership, and of course, human driven. We will move to a new type of mobility, new type of mobility model made by small and light vehicles, electric, shared, and autonomous, and of course, connected. But this is, let's say, the easiest part of the transition. What I would like to highlight is the fact that these 4 megatrends are not independent. So the real catalyzer of all the transition will be the automation of the driver. The automation of the driver will boost the transition to the servitization of mobility, so the sharing model. And the sharing model itself can boost not only the electrification, but also the size reduction. And the size reduction itself can also, let's say, facilitate the transition of electrification. So there are all these interconnections where the real starting point, the real big bang will be the full automation of the driver. So a few words about the so-called self-driving car. So this is the classical classification or roadmap towards the fully automated vehicle. So you know that, let's say, the autonomous car is classified in 5 levels of automation. So today we are at level 2. So today you can buy a level 2 car. The next transition, the next step, which is going to be an extremely challenging step, is from L2 to L3. Notice that from L2 to L3, there is no a major difference in the technology, but the real difference is that in L3, the driver is officially allowed to disengage. So there is, let's say, an official handover of responsibility from the driver to the car. So it's really a quantum leap from the regulation point of view, for the liability point of view. So this is the next step. So from L3 on, the next two steps are towards the fully automated car. So L5 is a fully automated car. So in principle, without a steering wheel, without, let's say, brake and accelerator pedal. Is it difficult to make an autonomous car? Yes. So in the last few months, it's common to quote a statement of Elon Musk in July this year that said so this is the quote. So I didn't expect to be so hard, but difficulty is obvious in retrospect. Nothing has more degrees of freedom than reality. So it was expected a few years ago that, let's say, moving towards a fully automated car can be reasonably easy. The fact is that let's say the autonomous car is probably the most challenging, sort of the ultimate challenge in a robotization of a human task. Why? Because there is a very long list of challenging features in the robotization of the car. Just a few of them: high speed, complex and fast vehicle dynamics, high safety issue. So there are humans on board, humans in dynamic obstacle around the car. The environmental conditions are extremely variable: grip, weather, type of roads, visibility, and so on. Mapping uncertainties, localization issues. So GNSS is not enough. So there are some places where you cannot fully rely on satellite positioning. Extreme multi-agent environment. There are a lot of, let's say, agent dynamic obstacle around the car. It's a hybrid robot and humans environment. Some cars can be driven by humans, and some cars can be driven by a robot driver, and this makes the complexity extremely high. There are gray zones in engagement rules, especially because of the humans. Extreme variety, type, speed, behaviors of dynamic obstacle. So from a bicycle to a dog to a pedestrian and so on. Extreme dynamics obstacle density, you can see here, essentially traffic, and so on and so forth. So this list can be even longer. So the message is an extremely complex robotization task. It will take at least another 10 to 15 years to reach a full automatization of the car. So what is going to happen? When we will have the fully autonomous car, there will be what I call the bifurcation in cars. So it's easy to predict that once the autonomous car will be technically ready, this bifurcation will occur. Today, this is the model of our mobility today. So personal ownership of the car, and our personal car is a mix of function and fun. So we can use it just for specific function to go from A to B, but also from fun. So it's so we like to buy the car with all the gadgets we like driving the car. So it's a mix of function and fun. There will be a let's say a clear bifurcation, a clear separation between the two functions. From one side, there will be a niche of emotional, I like to call the red cars. Let's say the objective of this car is essentially emotional. So they are toys in some sense. The largest majority of the car will be functional car, purely functional car, and there will be shared robotaxi. So it's using the word robotaxi. Let's say it's an easy way to indicate how this car will be used, and there will be the largest percentage in the long term. So this is a visualization. Today there are just a few examples, prototype example of robotaxi services. You can see here the AutoX in Shenzhen. There are a few other in the world at the level of experiment, at the level of prototyping. There are small fleets of robotaxi, but this is the direction we are going to take. Now let me enter in the discussion, in the presentation of the question about the reduction in volumes in a robo-taxi mobility model. So which are the numbers we can expect? Is it feasible not only in big cities, but also in medium-sized cities? So this is the question we try to address. Essentially, the question is how much and where. Let me start with a very simple answer to this question, a very simplified way to address this question. You can see in this picture, the picture from real data. So these are real data taken in Italy of the simultaneously used cars. You can see here, this is a weekday, this is a weekend day. This is the percentage of vehicles. So in Italy, there are about 40 million vehicles, 40 million private cars. So this is the percentage of simultaneously used car. And you can see that, let's say on average, during the day, during a weekday, it's no more than 7–8%. In the weekday, in the weekend, so 8% is the peak. There are some peaks at 12%, but just for a small amount of time. So all in all, if we just see the simultaneously used car, we can simply conclude that with 10% of the car today in a full shared, in a full robotaxi model. So current mobility model, current mobility requests can be fully fulfilled with just 10% of the car, which is really a revolution. So it means that we expect it to go from 40 millions in Italy to 4 or 5 millions in Italy. Of course, there will be correspondingly a let's say an expected increase of mileage. Okay, much less cars, much more sophisticated. There are professional cars that are taxi, and they are expected to have much bigger mileage with respect to the current mileage, annual mileage of a private car. But let's go a bit more in detail. So this is the analysis we have done. We have recently done. We have been using a very big data set. We have available all the car trips from telematic boxes, so taken from, let's say, insurance boxes. The percentage of cars we have analyzed is really huge. So we analyzed the data of 10% of the total of the cars. So this result have very high statistical confidence because we really analyze a very large percentage of the car. So the extrapolation we did is on a very big statistical basis. And what we did was to take some mid-sized city. So forget about the huge metropolitan areas like Milan or Rome or whatever. Consider, for instance, Padua. This is the example of Padua. And we consider different radius around the center. So we try to make the analysis parametric with respect to the area covered by the robotaxi or the car sharing services. The focus. So we first tried to let's say to focus on the vehicles with a high chance to migrate toward a car sharing model. Let's say we call them the car sharing short-term candidates. So they are cars that, because of their behavior, are very likely to be, let's say, to be ready for moving to a car sharing model. So today they are personally owned car, but they can be easily, let's say, moved into a car sharing model. And the idea is to take the car having 90%, so the largest majority of their trips that start and end inside the circle. So they start inside the circle, they can go around and stop here, but they can also move out of the circle. What is important is that they start here, they move around, and they end their trip inside the circle. So the circle is the area when you can take and leave the robotaxi or the car sharing car. So this is we call it in trips, and the car that today have 90% of their trips with this behavior are we consider them the real candidate for a short-term car sharing. So let's analyze some data. Let's see the data that we found. So the first chart, this is the chart, is the percentage of compatible cars with this meaning. So 90% of their trips is from inside to inside. So this is the percentage with respect to all the cars. And what you can see is that, let's say, of course, it's increasing with the radius. So it's all parametric with the radius. And you can see that with a radius which is relatively small, we are talking about 7-8 kilometer radius, they are already at 10%, which is already a big number of cars which are really compatible to car sharing. So if you move from 7 to 8 to 20 kilometers, which is still a reasonable radius for this type of service, notice that we go up to almost 50%. So of course, when you increase the radius, notice that from this point on is almost linear, the relationship between the radius and the percentage of cars which are, let's say, compatible with the car sharing today. The second chart is another very important chart, and is related to the efficiency, the so-called efficiency. Of course, again, with respect to the radius. So this is the number of users per shared vehicles. It means, so how many cars, private cars, we can eliminate and exchange them with a single robotaxi, with a single shared vehicle. So notice that, so for very small radius, this efficiency is small, then grows quite quickly, becomes quite high, let's say more than 1 to 10 at around 3 kilometers radius, has a peak of almost 20, ratio of 20 of efficiency at 5 kilometers, and then slowly go down, but still maintains a very high ratio. Notice that at 10 kilometers, it's still more than 10, it's 14, and then goes to 12 or something like that. So it means that there is a very big efficiency. Of course, keep in mind that simultaneously used car peaks are 10%, but we are restricting to a subset of people, so the compatible with car sharing. So we can expect a very high efficiency. We can remove 10, 12, 15 cars today, private cars, in exchange with one robotaxi that can fully provide the service without any limitation for today mobility. What about the mileage? What is the mileage, annual mileage, yearly mileage expected to this car? Again, as a function of radius. Notice that, for instance, with a 10 kilometers radius, the yearly mileage of a car is around 60,000-70,000 kilometers. Of course, can grow. So the larger the area, the bigger is the mileage. The growth is not that big. So what is really important, if you look at this number, is that let's say there is an easy break-even for the cars, and especially for electric cars. So you know that the big problem today for the electrification, that a private car in Italy has an average mileage which is less than 10,000 kilometer per year. So this is a problem. This is a problem because with this very small mileage per year, it's very difficult to reach a break-even especially for an electric car. So clearly, we can move to if we move to a car sharing model, the mileage for each car is much bigger, and this can guarantee a much easier break-even for the business model and specifically for the electric car. This is very important. The final chart is about the car density. Again, you can see here as a function of radius, the average distance between vehicles, assuming this is a theoretical assumption, so assuming that there is a uniform distribution of the car. Suppose that the cars are always uniformly distributed, like in squares, like in the corner of squares. A couple of remarks. So first of all, notice that in this case, there is a significant difference between different cities. You can see Vicenza and Verona has this behavior, Padua has this behavior. So it really depends on the topology of the area. So it's not obvious, let's say, the density of the car. So the second remark is that notice that if we look at, for instance, at radius below 10 kilometers, the density is quite small. So it's more than 300 meters. 300 meters in principle is a reasonable minimum requirement to have a good service level. So we are around, in this case, notice 500, 400 meters, assuming uniform distribution. But the problem is that it's very difficult to have uniform distribution. Typically, the cars, let's say, are so the density of the car is very different. So typically, it's very difficult to have the correct density of the car in the right position at the right time. So this is really the biggest problem today. So theoretically, there is the correct number of cars. Theoretically, there is a correct density. In practice, the density is not well distributed, and also if uniformly distributed is not enough. So it's clear that to go on a large-scale car sharing model, we want to really go in that direction. So the automatic allocation is needed. So the key point is that the autonomous car is not a nice-to-have technology to move into a full car sharing model, but the robotaxi, the technology of the robotaxi, is strictly needed. What is the minimum we need as a technology? We don't really need a fully autonomous car. What we really need is something that is similar. So in this video, you can see the smart summon of Tesla. So the easy reallocation, the easy automatic reallocation of the car. So in this case, the idea is that you can call the car and the car automatically, without driver, can come to you. Of course, this is an example, but just to visualize that this is the minimum requirement. So I call this an L4 level, but light. So it's driverless and it's low speed. So it's not a really very challenging requirement. And this will be the enabling technology to allow a large scale diffusion of car sharing. Before we have this function, it will be very difficult to have really large scale, intensively used car sharing services. So the automation is not a nice to have, but it's a mandatory requirement for having a massive diffusion of the servitization model for mobility. Last question is a classical question. What's about the timing? So I like to show this chart. This chart just says that so the question is, in 2035, what will be the percentage of L3 or more cars? And you can see from this chart, estimation can be from 10% to 95%. So it's extremely difficult to make a prediction. Of course, in the long term, we will go to 100%. Why so difficult to make a prediction? Because there are regulatory issues that can dominate this transition. Let's say the development of the autonomous car is still to be fully developed. And of course, reaction of user, so the feeling, the perception of user can make, of course, a difference. Let me conclude my presentation with a remark on another transition that we are all experiences. So far I've been talking about a transition from this classical mobility model to the new one, but it's physical mobility. But we are going also rapidly into a virtual mobility. So let's say the pandemic accelerated a lot of this trend. So today ICT technologies are evolving much faster than vehicles and transport systems. So no safety issues, let's say no physical safety issue, maybe mental issues, no major infrastructure investment. So in principle, we can envision easily a future with a limited personal mobility. So from one side, we have the robotization of the car, so the robo-taxi model, let me call it the Uberization of the mobility. From one side, we have what I call the Amazonization of mobility, so the transfer of mobility from people to goods. So in the future, we will see probably a decrease of need of personal mobility for people and a significant increase of mobility for goods. So the logistic, the transportation of goods. You can see here an example of a project developed for a last mile delivery with a small, let's say, a small autonomous robot, say level 4 on pedestrian area, or you can see in a more, let's say, visionary way. This is a video from Continental Corporation. You can see the mail dogs that can deliver, let's say, your mail in a fully autonomous way. So let's go to the conclusion. We can see two scenarios in 15, 20, 25, or maybe 30 years. This is the timeline of this transition. So the scenario number one, this is the one I like more. So I say it's a bright and safe future for the city. So it's a robotaxi, much smaller number of cars. So the cars will be, the cities will be free from parked cars, from the big numbers of car moving and staying and occupying space in the cities, just a few number of cars, electric, robotaxi model, very safe, leave room to the soft mobility, so bicycle, pedestrians, and so on. So this is, let's say, the nice part of the story. Or we have to consider that we also there is another direction that we are taking towards a full digital world. So the world of metaverses, the world of let's say virtual reality, and you can bet this direction or the other one, probably a mix of both. In some sense, we can decide. We can decide to move towards scenario number one and scenario number two. Give me just 1 minute to conclude this my presentation. So in the development of the autonomous car, which we understood it's a real big bang of all this transition. So 2021 was the birth of autonomous motorsport. I like to quote the India Autonomous Challenge recently took place in Indianapolis, the Robo Race initiative, and there are some other initiatives which are emerging. So why autonomous motorsport? The motivation is that so motorsport traditionally has been, let's say, a place to develop new technologies. But what happened in motorsport is that the level of development of automatic control, robotization, and artificial intelligence, let's say, didn't follow really the development of, let's say, the automotive. So this is the growth of this technology in motorsport. There was some, let's say, increase and then down, increase and then down, because typically the automation of the car has been excluded by the development of the in the motorsport, because let's say the emphasis was on the human driver, on the pilot. And so what happened, what is happening is that is a total divergence between the level of technology of let's say, robotization in cars and the level of technology in everyday cars. So this gap doesn't make any sense because racing is typically a way to boost and to develop the most important technology. And so the birth of autonomous motorsport was intended, is intended to fill the gap, this huge gap that there is today between the level of automation of let's say, a public road cars and the top motorsport. Let me conclude with a picture I'm very proud of. This is Politecnico Milano autonomous racing team. We are competing in all the main autonomous car competition. And with this image, I would like to thank you for your attention and enjoy the rest of the conference today. Thank you very much.